of how to write functions using this function notation and so forth. But now let's think about the functions again as visual objects, as graphs in the plane. Now, we know that all functions, of course, will pass the vertical line test. But what about the values that actually get hit and the allowable values that we can plug into the machine? You see, there may be a function where there are some x values you just aren't allowed to plug in. For example, if the function had like a square root in it, you can't make the inside of the square root negative. That would not be allowed. Doesn't mean it's not a function. It just means that that x value is not allowed. Well, the x values that are allowed to be put into a function, those x values form the domain of the function. The domain of the function is just the collection of all the allowable x values that can be input in without any fear of problems. For example, if you had a function that had denominators, well then any x value that would make the denominator equal to 0, that would be off limits. So in fact, those points would not be in the domain. But now we can ask another question. We can say, okay, fine. So there are these values that, only certain values of x that you can plug in to make this thing, be a function. But then what about on the output level? What are all the possible values that we can get, as output? Well, that's actually called the range. So the range of a function is just the collection of all the y's that we might actually have as output. Okay, that's a lot of mouthful of stuff. Let's take a look at this visually, and you can see the differences between the domain and the range. Now let's take a look down here at this graph. Now this graph is a function, and you can see that by just giving it the old vertical line test. It just hits always at most 1 point, so definitely a function, no problem there. No loop-to-loops, basically, no loop-to-loops. That's what it means not to be a function of x. And so here I'm using the notation y, the height, is a function of x, is f of x. It means to find out what y is, you have to input an x value, and it spits out a y value. So for example, if I say to you, what's the y value here, at this x value, you take that value of x, you plug it into the function little machine, it spits out something, and it's that height right there. It's that height right there. Okay, so now, what's the domain and what's the range? Well, see, the domain is just all the allowable x values. So wherever the function actually is defined, in fact, that would constitute the domain. So in this case, of course, you have to pretend there are little arrows here. I just don't have arrows to see. You have to keep going. The domain in this case would be everything, because in fact, no matter where you plug in, the function, of course, keeps going. Not of course, but I'm telling you, it keeps going. So in fact, here, the domain would be every single thing. Now, what about the range? Well, if you look at this curve, this function, you see that this seems to be heading up, and so if we extrapolate, now of course I am extrapolating here, and you might say, well, how do you know at some later point in life it doesn't bend down? Well, okay, it's true, I don't know that, but just if we play along for a second and I tell you that in my mind, in my special world, this thing just keeps climbing like this, then you can see that all the big values of y are going to get hit. You see that? Like if you go way up here, that will be a value of the function for some point, and similarly for the higher and higher values. However, it's not true down here, right? In this no man's land here, the function never dips that far down. So in fact here, the range would have some limitations. This is not in the range. There is no value of x that has the function down here. And in fact, if you look at this carefully, you'll see that the lowest value the function comes down to is around somewhere this height, right? It's sort of like a limbo thing. How low can the function go? Well, it turns out right to here. So in fact, the range of this would be all the y values that are this point or higher. This point or higher. But notice that if you pick any y value below that point, like let's say right here, the function never ever comes around there. So this point is not in the range. The function never actually crosses that point. So the range are the y values that you actually hit. So imagine taking this picture, if you will, and just projecting it right down to the y-axis. Where is the blue? If you project everything down and squash it all down to like a one-dimensional thing, just you'd see blue all up and down here, but you'd see no blue over here because there'd be no residue. So in that case, the range would just be wherever you'd see that blue residue. The domain, you just project down this way and see where the blue residue is. In this case, since these things go on, the blue residue would be everywhere, so the domain would be everything. Okay, let's take a look at some more specific examples and get a sense of what the domain and range would be here. So here we go. I have a whole bunch of them. I've got more examples than you know what to do with, so don't worry. We will not run out of examples. Here's the first one. Here's a function, and you can see the arrow indicates that it keeps going up like that, and then it comes down, up, down, dip, dip, it goes down. So what's the domain? Well, I'm looking for all the x's that I can plug in for this. Well, one way to think about it is just to take these values and just project them down and see where they line up on the x-axis. Well, if you think about it, this is going to line up on the entire x-axis. So the domain of this is actually everything, all the x's, so the whole real line. What about the range? Well, do the same thing now onto the y-axis. Just take each point, so take this point right here. I need a hand. This one. Take this point right here and just project it over here and project it over here and see if there are any values that aren't hit on this line. Well, if you think about it for a second, you'll see that every value of y will get hit at some point because this thing keeps going up and up and up and up, so that's going to take care of all the big values. This goes down, 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 takes care of all the small values, and then everywhere in between we've got these values taken care of. Maybe even more specific than that. Suppose you pick a particular y value, like let's say the y value right here, -1. Does that get hit? Yeah, it gets hit by something like maybe, what does it look like? About 9.5 maybe? If you let x be 9.5, so let x be 9.5, what's the y value? It looks like it's -1. So -1 gets hit, -1 is in the range. So in this case, the range would be all the y values. Let's take a look at another example. What's the domain of this function? Well, the domain of this function, well, let's see. What are all the allowable x values? Well, looking at this, I see that all x values are allowable because no matter where I pick an x value, I can always either go down or I can go up to the graph. So in fact, here, domain, everybody. What about the range? Do I hit every single y value? Well, this arrow down here, this arrow down here shows that I get all the negative values. So all the negative values of y I do get, right? For example, if you say to me, what about -1, 2, 3, 3? What about -3? Well, you go over to here, and you say, oh, that got hit by something. It looked like it got hit by about maybe 3.5. You plug in 3.5 into this function, and you'd get -3. But what about, like, 14? If you go up to 14, that would be, like, way up here somewhere. Does the function ever cross that height? The answer is no. The function's way down here, comes up, never makes it that high. So, in fact, 14 is not in the range. Is not in the range of this. And in fact, what's the range? It looks like the highest point we hit is 12. So the range would be all the values for y that are 12 or smaller. So we don't get to hit every single y value. There's no way to hit 13, for example. So here, the domain is everything, all the x values. The range are just the y values that are 12 or lower. Let's try another one. Here's a function that's actually a little bit peculiar, but they really do happen. This function just sort of starts right at -6, doesn't exist even before that, and then zips up. So what's the domain of this? Well, the domain, you can plug in any of these values here, and this keeps going up, but you can't plug in -7, because -7, the function's not even there anymore. So in fact, here's an example where the domain is actually not all the x values, it's just the x values from -6 and larger. From -6 and larger. What about the range? Well, notice that no negative y values are ever hit. So in fact, the range is just from 0 and all the way up to infinity. And you can see that by, again, thinking about this projecting thing. Just take all the points and just sort of slide them back to the y-axis, and you'd see that all these things would be red right here, but there'd be no red down here. So in fact, the range would be just from 0 all the way up to infinity. Oops. And the domain is from -6 out to infinity. Okay? Here's another function that has endpoints. This has 2 endpoints. It just starts here and finishes there, and that's it. That's the whole activity. So what's the domain? Well, the domain are all the x values between -3 and 4, because the function is just not defined. There are no arrows there. It's just not defined outside of there. So this is a function whose domain is a very limited collection of x values, just between -3 and 4. Maybe this has some sort of square root thing in it, where you can't put in big values of x or small values of x because the square root would be negative or something. I don't know what the function is, but you can imagine such a scenario where the only allowable functions for x that the machine will actually take off and not crash are the values between -3 and 4. What about the range? What are the values that get hit? Well, again, you can just think about this as taking the function and just pretending it's movable and just sliding all the points to its appropriate y counterpoint, sliding them over. And where would you see red? You'd see red between -6 and 8, and that's all. So in fact, here, the range of this function are just the y values between -6 and 8. That's the range. Okay, let's start picking up the pace here a little bit. Here's another function that starts right here and ends right there. What's the domain? The domain is between -5 and 4. -5 and 4, that's the domain. Everything else not in the domain. What's the range? Well, the highest point the function gets is 6. The lowest point is -2. So the range is between 6 and -2. So the y values that get hit are between 6 and -2. Remember, the domain, those are x values, and that's between -5 and 4. Okay? One last one here. Here's a function that sort of has some straight line segments to it, but that's fine. Again, this cut off. So what's the domain? From -4 to 3. That's where only the place of the function is defined. What's the range? The highest point is 6. The lowest point is -5. So the range would be from -5 to 6. Those are the y values. The domain would be x values from -4 to 3. So you get a sense of the range and the domain. It's very important. In fact, the domain is very, very important. I want you to feel really comfortable with the domain, but even more comfortable with the range. In fact, I really can honestly say I want you to be at home on the range. Sorry.